Welcome to 1.1 Inductive and Deductive Reasoning. This is the first video for Class 1103. So now we'll attempt to explain to you the difference between the inductive and deductive reasoning. I will tell you that this class is more of reasoning and more of reading and definitions, but it starts off well. It's something that I think that is doable and that you all can do. Okay, so it will seem as if I'm reading to you, but I will try to explain to you to see if you can catch on the different differences. Inductive reasoning is a line of an argument that takes specific examples. So the key word for inductive is specific examples, and deductive uses statements that are commonly accepted as factors. And so this chart is trying to give you a little hint. So if you're dealing with inductive reasoning, you have specific observations. And if you're doing deductive, you have accepted facts. And so the good thing about the videos, you can stop and start or pause if it's something that you do not understand, or and rewind and replay. So determine whether the following arguments use inductive or deductive reasoning. In Boulder, Colorado, it snowed 16.2 inches during January 2019 and 16.3 inches during January 2020. Therefore, Boulder will receive at least 16 inches of snow every January. So would this be inductive or deductive? This would be inductive because you have these specific examples that lead to your reasoning. So this is an example of inductive. All even numbers are divisible by 2. The number 2,045,890 is even. Therefore, this number is divisible by 2. This is deductive because you know these are the accepted facts. To get a bachelor's degree at Georgia Southern University, a student must have 120 credit hours. James is about to graduate from Georgia Southern University with a bachelor's degree in engineering. Therefore, James has at least 120 hours on his transcript. This would be an example of deductive because you have these accepted facts. Colleagues in the office have determined that the optimal time to leave work is 4:42 p.m. based on traffic patterns they experienced over the past 2 weeks. So they are basing this off of their specific examples. So this would be inductive. Now we're going to look at patterns. Use inductive reasoning to identify a pattern in each of the following sequences of numbers in order to establish the next term in the sequence. And so there are two different types of patterns. Sometimes it's arithmetic, and geometric. So if you're dealing with the arithmetic sequence, just know, think about adding and subtracting. Think about arithmetic. Squeeze that in there. And then if you're dealing with geometric, they will multiply. And I know you have some of those in your homework in your certified section. So geometric is more of you're going to look for the multiples. So 4, 9, 15, 4, 9, 14, 5. What do you do to the 4 to get to the 9? What can you add to the 9 to get to the 14? What do you add to the 14 to get to 19? Each time you're adding 5, so the next number would be 24. All right. And the next one, you are multiplying times 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So 54 times 3 is 162. So this would be a geometric, and this would be, the A would be your arithmetic because you're adding 5 every time. So for the next one, it changes. Plus 1, then they add 2 to 6 to get 8, then you add 3 to 8 to get 11, and so the next number would be 15. So this would be, it's just different. So this would be neither, and some of them are that. A certain type of human cell reproduces in the following manner: 1 cell, 4 cell, 3 cells, 16 cells. Determine the number of cells present on the next production of cells. So you have to kind of look and see what is the pattern. This is the first one, this is the second one, this is the third one, this is the fourth. If you look into it, you can see that each time it's doubling. So if you did 1 squared, you get 1. If you did 2 squared, you get 4. If you did 3 squared, you get 9. And this is how many we have in the figure. If you did 4 squared, you would get 16. So the next one will have to be 25 because it will be the fifth picture. And 5 squared would give you 25. And so how many cells will be present in the nth reproduction cycle? You would use the equation n squared. Oops, sorry. So this would be n squared. So now we're going to read situations. Use deductive reasoning to choose the correct conclusion for each argument. My state requires all lawyers pass the bar exam to practice legally. If I do not pass the bar exam, then I blank. The answer would be number 1, will not be able to represent someone legally in my state. Because number 2, it says we'll have to take the exam again. You do not have to take the exam again. But you know what the accepted fact is that you will not be able to represent anyone, but hey, they can't make you take the exam again. So number 2, the tutoring center at my college is offering free exam reviews to students. I'm a student and I plan on reviewing for my sports management exam. So I am number 1, will pass my exam, or number 2, will not have to pay anything for this service. The only thing we can guarantee is number 2, because just because you go to tutoring does not necessarily mean you're going to pass the exam, unfortunately. All right, so C. My boss said that the person with the highest sales would get a promotion at the end of the year. I generate the highest sales, so can you conclude that number 1, am participating in my promotion and am anticipating my promotion, or 2, am the highest earner in my workplace? Well, it has to be number 1. We cannot assume that you are the highest earner in your workplace just because you generated highest sales. So you can anticipate a promotion for sure. And the next slides just give you the answers to what we just concluded. So this is the conclusion of 1.1. Hope you are encouraged to continue. It is a lot of reading in words and not a lot of computation, but hopefully it's enough to keep you encouraged to keep on with chapter 2. So I will continue with the next videos in the following YouTube videos to come.